Yep, recording is now on, and we will kick off the meeting. So again, I've pasted the link to the agenda document into the Zoom chat, so you can kind of follow along with us. We basically had a pretty short agenda, but we can also go over the changes to the document. I sent out a mail earlier today talking about the changes that I had made based on last week's, or excuse me, 2 weeks ago meeting. And I think the biggest changes were...
The date is wrong, right, for the agenda, just so I not have time worked.
Yes, it should be February 1st. Okay, so the biggest changes to the standard were, and actually let me just add an agenda item. Discuss changes to the de facto CRD spec. Okay. All right, so those changes were, I had clarified that the runtime meta plugin must always attach the pod to the cluster-wide default network, keeping the existing queue behavior, and then any additional, or any network specified through this specification, and the annotation would be additional sidecar networks. I have a link to the video there where that was discussed from last time, and the time on that, so you can, if you want to go back and look at that or listen to that and the reasonings for that, that's there. I think that was one of the big changes. I removed the bits about default network stuff. We had also discussed that quite extensively in the last meeting. And just to recap on that, that was a question of what network gets reported to Kubernetes, what network gets the default route, and what network gets used for health checking. Because of the change for always attaching the cluster-wide default network, those questions mostly disappear, because the cluster-wide default network will obviously be the one that gets reported back to Kubernetes, and currently that will be the one that gets the default route, and so on.
Question there?
Yep, go ahead.
I still notice there is still a bit of default mentioned in the status.
Yep. Yeah. So I thought about that a little bit, and it seemed to me that it would be useful for the the additional details of that network cluster-wide default network to be shown in the status annotation. And so the intent there was that if you need some consumer to know what interface name that cluster-wide default network has, any additional IP addresses that it has, what the MAC address was, then that would be reflected in the status annotation. But of course, Kubelet doesn't care about half of that, and the only thing Kubelet cares about is the first IP address on the interface.
So the idea here is this is an entry in the status map that corresponds to no entry in the specs annotation.
Yes, and that is a good point and might not be clear. We could remove this, but it seemed like something that was useful to me. I'm happy to go either way on that.
Quick question on the default route. So I sent you the mail, sort of the VPN. I tried to find sort of a simple use case that fucks up all networking. And VPN is a typical use case, because then you have the other side pushing your routes. And many enterprises push the default route for security reasons. And if you push that into the container, then you have this complete split, right? So I don't know if I asked Suresh to explain it. I was looking for a simple use case that creates havoc, that sort of does not bring in all this when we talk about, I'm going to build an L3 router and use Kubernetes, because I think that most of the problems already exist with such a simple use case. And then we have to make it clear that you cannot do that. What are the boundaries that you're supposed to be able to do, or show sort of what does it take to be able to do such a simple thing.
Yeah, we talked about it last week in detail. Yeah.
Hi, Suresh. I just want to do.
Yeah, I do remember quite a lot of discussion on that, and I mean, to be clear, Kubernetes doesn't actually care what the default route is, and I don't think there's anything in CNI that would prevent...
I agree. It's very much how you configure and set up as a service provider that sets those things.
Yep.
So Dan, like on a completely side note here, like I remember Clayton telling us, like, there's like this 17 ways of extending Kubernetes or something like that we should look at before we do this. Did anything come out of it? Because I don't remember like a pointer to that.
Yeah, I don't think there was a pointer because some of the extension points for network type stuff aren't either aren't there or aren't well defined. Mike, actually, you had talked in the past about using what is it called, an overlay API server or whatever that's called for some of your stuff.
The term, I believe, is aggregated API
Yes,
server?
that's it. Yep, so that is one extension point, but some of the other things that people are really interested in, like kube proxy and obviously like network stuff like this, don't really have extension points yet. So that's something that we could discuss further along the road if we find common places that we do need extensions.
I would say,
Okay.
I mean, we are talking about extension points here, right? The ability to put annotations on is an extension point. The ability to deploy additional controllers is an extension point. So some of the most fundamental ones are still the most powerful and most of what we need.
And also scheduler. I think there are some ways to do scheduler plugins, and that's a pretty big one for some of this stuff because you might not be able to run a particular pod on a given node if it doesn't have some of those network resources. So, and most of this stuff is explicitly left out of this document for the moment.
Mm-hmm. And for that sort of thing, you would probably also want an admission controller to automatically add the scheduling constraint.
Does that kind of answer the question, Suresh, for the moment?
Yeah, it does. Yeah, thanks.
Okay. Yeah, I mean, definitely if you start thinking about extension points, it'd probably be fair to bring those up on the sig-network list because I think they're of general interest and they're not just of interest to this, kind of multi-network or network plumbing community.
Like a thing that we need to pass through some checklist before we can take it upstream cube. That was like more my concern, right? Because the way Clayton spoke like made it sound to me like that, right? Oh, do you want to take this up like upstream cube? Then you have to tell us like why these other things don't work. Yeah. So maybe I understood that wrong, but that's the kind of subtext I saw in what he said.
Yeah, what I got out of that conversation was generally that Kubernetes is upstream trying to take a philosophy of adding extension points rather than trying to add a bunch of code and new API and stuff to Kube itself. It's kind of a way to manage the project and keep things that aren't of extremely general interest to all of Kubernetes out as kind of third-party plugins or other things that people can just add in. So that was my takeaway from that. And I would expect that as time goes on, we probably would add more extension points for network specific stuff.
Okay, sounds good.
Yeah, and I mean, I think also it was kind of an encouragement to start thinking about this. And since all of us have some common use cases, but then we all have our individual use cases, extensions do make some sense because they'd allow us to obviously do the stuff that we want to do that not everybody else needs to. So figuring out where those are is definitely something that sig-network should be involved in. Also, getting back to the default route discussion, I did add 2 sections at the bottom of this document, as we talked about last time, which were open questions, which we could discuss today if we ran out of things to discuss, and then previously discussed topics. And one of those was the defaultness question. And we made a decision last time to always attach the default Kube network, and all networks specified by the CRD as our sidecars, which not refer to Kube, and thus the default gets, the default route theoretically and all that kind of stuff. But then we kind of punted for the future, splitting up the concept of defaultness to perhaps allow not attaching the default Kube network and also specify which networks get passed back to Kube, which ones get the pod default route, and like which ones are used for health checking. Trying to think of other big things that changed in the document from last time. Oh, I did add, and I'm sure you probably saw this, Mike, I added the status stuff. I think you had requested that from the last time, or something like that. And so I added a kind of example in for what that would look like and changed it to a dictionary, I believe.
Yes, you made it a dictionary, a map.
Yep. So that is changed. So yeah, okay. So that's it. If anybody
On
has
the entry on the set,
Go ahead.
that. I was just going to say, if you're going to have an entry in that dictionary that's not in the other dictionary, you have to define what its key is.
Yeah, that would be true, and I should add something about that. I'm assuming that the key would be the network name of that default network, since the runtime plugin already knows that. It has to know that to be able to exec it in the first place. But I will add a note for that. Any other general thoughts? We can also start talking about some of the comments if you want.
Yeah, I mean, I started looking. I got most of the way through reviewing it just before the meeting, so
yeah,
I can have some discussion.
Okay. I mean, we might as well start talking. I wonder if Dan Winship's on. Is Dan Winship on? Winship is not on. So Winship had asked about whether the MAC address is useful. I think you had talked about MAC address in the past, Mike? Is that something useful to have in the status?
Yeah, I'm afraid I've got colleagues, who want to do Ethernet level stuff. So obviously they're going to care about MAC addresses.
Okay. I mean, I'm fine with that for the moment. Also, I know that there are some cases that will not necessarily be IP-based connectivity for some of these sidecar networks, since that would be the only way that you could really identify that interface.
That may connect to another comment I had. I was figuring we're talking about the usual stack. If we've got a really unusual stack, I'm not quite sure what we've got.
What do you mean by unusual stack?
Well, usually you've got IP, and then usually, not necessarily, below it something that's got MAC addresses, like Ethernet. And of course, there are protocols layered on top of IP. So I was assuming that the MAC we're talking about here is the one that's below the IP layer.
Yep, I would agree.
So I saw an example of InfiniBand over IP. I was assuming that is InfiniBand over IP over Ethernet.
Sorry.
The MAC would be the Ethernet MAC.
I got that wrong. An IP over InfiniBand.
Sorry. Okay.
That's my fault. Yeah, so InfiniBand Macs, I think, are like what? Really long? 128-bit or something like that. I forget.
I'll delete my comment then. That's was just.
I'll resolve it. That's fine. I did that. Yeah, IP over InfiniBand. So in that case, it is IP, but obviously the link layer is InfiniBand, and so the MAC addresses will be longer. I just tried to throw that in to make it a little bit more generic than just Ethernet, since I know.
To observe and read the MAC, or also to manipulate?
Can you say that again?
Just observe the MAC address, or to be able to set and change the MAC address? I assume it's observe.
Yeah, in this case, for the status annotation, it would be the observed MAC address.
Yeah. Because otherwise you start crawling so far down in the in whatever that's underneath that it doesn't seem to be the place to do that.
Although that does bring up another question that maybe we want to talk about, which I think Mike had brought up, which is also in the open questions section below in the specification, which is pod attachment specific properties. For example, if you want to be able to specify the IP address and the MAC address or the MAC address for a given pod network from the Cube API, obviously that is pod specific. It is per pod per attachment. It is not per attachment.
No, I mean, I think definitely for the sort of stuff that we are working on, where you create L2 networks on the fly, and then you want to be able to attach a router to it, it would be nice to be able to shoot it. We create L2, and I mean the MAC address anyway. If you have to specify that in this, not sure.
Okay.
But what would happen if you say you want to have this MAC address? Then you have to sort of set the virtual MAC on whatever interface that you're giving this.
Yep.
Suresh, what do you say? He's taking care of his kids, I think.
Yeah, there already is a CNI convention.
Put on mute.
Go ahead, Suresh.
No, like so. I don't have like a very, very strong opinion, but I don't think that's weird to start off with, right? Like, so this is, I think it's like a pretty common use case.
To set the MAC through the pod directly?
Yeah.
Okay, so the CNI would set the MAC on whatever it brings up?
Yeah.
Yeah.
And there is a CNI convention for specifying a static MAC address that is only currently honored by the host local plugin. But since it's a convention, we could theoretically repurpose that for any other IPAM plugin, which means that, you know, if you're writing your own CNI plugin for this, then you could consume that value.
Yeah.
Well.
Yeah, and there's also like some work ongoing that like I'm kind of like kicking off to make sure that like DHCP can hand out like MAC addresses like on a temporary basis, but it won't be like done anytime soon. This just kicked off. So like there's IEEE doing some work to like figure out like how you do the temporary MAC address assignments in like a consistent fashion. And so there's like some work ongoing. So like the DHC plugin for the IPAM would also have some way of getting the MAC addresses in at some point.
Well, then we have the answer.
No, it's not not an answer, but like
it should be possible in that case to also on the Mac to say DHCP pretty much,
right?
Not just on the IP, and have a CNI fixing that because you have an IPAM that can support it.
Right, like and to be very frank, this is much easier done in V6 than in V4, right? Because in V4 this is GI add, and like so the MAC address becomes the identifier of the client pretty much. So it becomes much harder. In V6, there's like other stuff, like, you know, we can have a UUID as the identifier for the DHCP client, and then it makes us easier to just get a MAC address at that point. But there's like work to do, but I can probably share like an initial draft sometime in March, how we plan to do this. Like there's an IETF meeting in London where I'm going to discuss this with like Cisco and like a bunch of other people. So we'll have, I can share like some early thoughts probably at the end of March.
Okay, sure, yeah, send them to the list. I mean, that also, moving on from that slightly, if this seems useful, then how do we represent it? I think Mike in the last meeting had proposed making the annotation on pods slightly more complicated so that instead of being a list of strings, it would be a map. So instead it would be a map.
Can I finish quickly? Can I wait to go to party class?
Hey, Suresh, mute.
So yeah.
Hey, I am done. Yeah, thanks.
So if it was a map, the only downside I can see to that would be that it would be slightly harder to specify the annotation, or slightly more verbose to specify the annotation for users who wouldn't need to set a specific IP address.
Couple of comments here.
Sure, go ahead.
First off, in general, Kubernetes tries to follow the style that says for any map, the keys are defined at developer time, not you don't put runtime data in the keys. So in this case, right there, it would be actually a list of objects with a name field rather than a map. And if we follow that approach, that it's a list of maps, well, you know, at least as long as we're just slinging JSON here, we can say, well, we'll take a list of either map or string.
could do that. Would that not be a little bit more complicated in the code?
Yeah, it would.
Because you'd have to decode one type, and then if that failed, decode the other type, right?
Well, JSON, I mean, come on, any runtime representation of JSON is going to tell you whether it's a string or a dict.
True. So I don't know. I don't have any strong feelings on this.
Yeah, I just want to say, what do I want to say? Well, this gets connected to some other issues. I wonder if we can separate. I'm trying to think about what can separate them. Yeah, I guess. Yeah, I think we can separate it. So whether it's a map or a list of objects with a name field, I think is a separable question. It's merely a design style, but I've seen that the Kubernetes, somewhere there is a strong expression of this design style, and I've seen things getting changed to follow this design style. So, we might as well do it because it's the style that Kubernetes is preferring in general.
When you say do it, do you mean the separate object or the?
Yeah, I mean, instead of a map from whatever kind of key you want to the rest of the information, or I'm sorry, right, for the spec you're supposing just a list of string. So instead of, oh, I see. Okay. So for the status, right, the status is contrary to the usual design because it's putting user data in the keys in a dict, right? So the status should be rather a list of objects that have a name or reference field or something that gets correlated back to the spec.
Right. Yeah, I mean, we sort of talked about the pairing objects in the previous call as well. And I think all the kind of, I'm not disagreeing with you, but I think all the downsides apply there. You have to have other objects, another CRD.
No.
Right? No?
No, I'm not saying that at all. I'm just talking about a small syntactic change. In your status object, rather than having a mapping from keys, which are network references, to status of that particular attachment,
yeah.
Instead, you have in the same one JSON annotation a list of JSON records. Right,
got it.
That have one field that is that reference that gets correlated back to the spec.
So in other words, instead of making it a map, just do a list of maps, and one of those keys is the name.
One of the fields is what you correlate back to the spec.
Okay. How about for the pod annotation for network selection, which I think is what you were referring to earlier for static IPs and static MACs?
Right. I've been calling that the spec, right? We're talking about two annotations that really follow the spec and status model in Kubernetes.
Yes. Okay. Fair enough.
Okay. So I've been calling that the spec. Right. So the current design here is that it's a list of strings, which are each string being a reference to one of these objects. I would suggest that instead it's a list of, again, a JSON. Well, the JSON term is object, unfortunately, right? But it's a dict or a map, right? It's a record in ordinary terms. And one of the fields of that can be the string that refers to the network, attachment factory object. And that gives us the option to have other fields that carry other things we want to put in the spec.
What do other people feel about that or think about it? That obviously is more flexible.
So I think that one thing is for designers to go through. I have no problem with that. The designer that implements have to go through more complicated lists and so on. What I care about is really what it looks like in the annotation. So it's not too easy to make too grave mistakes.
Okay. So what I'll do is, why don't we just try that out for 2 weeks and see what people think? So I'm happy to update the de facto spec to match that for both the status and the spec annotations. So I'll just go ahead and do that, and we'll see if we like it, and if we don't, we can change it back. All right, let's see next. Let's see, is Corral on the call? I guess not. So he had an interesting question, which was, should we specify how the runtimes and meta plugins specify the interface name for CNI plugin? So what happens is when you call a given CNI plugin or a CNI config list, you are required to specify an interface name, and the plugins are required to honor that interface name for the interface that they actually attach in the pod. Technically, that's how those are the requirements of CNI. And so given that, for a plugin that implements the specification of multiple networks, do we need to do anything about making sure that interface names passed to each of these networks does not clash for a given pod? Does that make sense? You're looking a little confused, Mike.
Yeah, are you saying, should we do some checking that the user isn't requesting conflicting names?
No, because the user currently cannot request those names for the network interface. So what happens currently is that kubelet actually passes ETH0 as the requested interface name for the single cluster-wide default network. I'd imagine that doesn't change, but that brings up the question of what do we do for the sidecar networks that are specified by this document.
Right.
Do we require that the meta plugin picks different interface names for each one of these and kind of keeps track of interface names internally, which I think would probably be the most obvious choice, but maybe not the best?
Why would it not be the best?
Well, I mean, obviously the best might be to let the network, the individual plugins themselves that this meta plugin calls, figure out what that network interface name would be. But currently that's not the way.
Some of them actually have constraints on what the name looks like, right?
Yep. Probably, yes.
So we probably have to let that happen.
I mean, that said, currently there is nothing that prevents the plugin from not using the given interface name in CNI. CNI doesn't care. It doesn't actually check what the interface name is coming out of the call. So you can sort of get away with using a different name and just report that in the spec, or sorry, in the CNI result. But there are some plugins that do use that interface name, especially the default reference plugins for CNI. And so we do need to figure out how that should work. I mean, obviously we can leave it up to the meta plugin. We could just say meta plugins should ensure that CNI if name that is sent to each config or config list is unique for that given pod. If that sounds acceptable, I can just toss that into the document.
Well, so I think we should have independence between the, you're calling it the meta plugin. I'm thinking of a daemon process. We probably don't want to get into that detail at this point. Your point is there's some kind of code that's invoking CNI plugins to make these individual attachments.
Yep.
We want some independence between that code that we're kind of designing here and the individual CNI plugins themselves that get called.
Yeah, I think for the most part, those are completely independent at this time.
So the problem is that some of the CNI plugins that get called have an opinion. Well, if they're CNI plugins, they actually can't. No, they can. That's right. CNI gives the caller the, yeah, this is the problem.
Yeah,
right?
CNI technically requires that the plugin, I think per the spec, requires that the plugin use the given interface name.
If there's one given. But it allows the caller to not give one.
I think it might require a name. Let me go and check.
I also think it's not required. It can be given, but not always.
Yeah, I mean, this is an evolution from an earlier CNI in which it was not even possible for the caller to give a name.
It looks like as of current CNI, if you use the Go library to build your plugin, that CNI interface name is required. Also, the specification says that if the plugin is unable to use the given interface name, it must return an error. So some background on that, I think that we might be able to change that in CNI in the future, because I think that was mostly historical before CNI was able to report the interface names that it actually configured back to the runtime. This was actually the only way that a runtime would know what the interface name was. So there might be some possibility to change that. And again, like I said, it's required.
Okay, I remember it backwards.
Into the plugin.
Right. Originally, it was necessary. It was a required parameter.
Yep.
So I thought I thought that it had been deliberately loosened so that it was no longer required.
I remember something about that, but I think what you might be thinking of is the network namespace on delete.
No.
That's the only not required parameter that I can think of that's changed in the past year or so.
I really wish Dan Winship were here. I thought he's been talking about this for a year, and
well, I mean, in the end, it does currently look like the interface name is required. We could, I mean, what I'll do is I'll just update the specification, the CRD document here, to say that the meta plugin is responsible for ensuring that the interface name sent to each CNI config list invocation is unique for that pod, which isn't that hard, because to actually run multiples of these, if you want to run attachments to every single network that's specified in the pod annotation, you're going to be doing that most likely in a single executable invocation anyway. So you'll already have that information, and you can kind of mediate between those. And I'm pretty sure that Multis and CNI Genie already do this, FYI. Okay, so next one is, see, I'm kind of punting the resource thing till the end, seeing where we get with that, but multiple attachments to the same network, which I think is something you were talking about quite a bit in the comments, Mike.
yeah, I'm sorry, but you know, my colleagues are not telling me that, you know, they can live with only one attachment necessarily. And I thought I'd also heard from some of the other people around here that their use case may involve multiple attachments to the same network.
Yeah, so, and I think as I'd said in the comments, you can solve this by creating additional network attachment descriptions that have a separate network name. And then selecting multiple of those. Yeah, and I think in the comments you had said that the pod author may not be able to create these, or the pod creator may not be able to create additional network attachment.
That would be one problem,
etc.
Right, that'd be one problem. The other is that elsewhere in this document, it's stipulated that when the CNI plugin is invoked, the network name it's given is the name of the Kubernetes object.
Correct. It is expected that currently that the name of the Kubernetes object and the name of the network configuration from the CNI JSON will be the same.
So if someone wants multiple attachments to a pod of the same network, he can't have two Kubernetes objects with the same name.
Correct.
So there's a disconnect here. This is not going to work.
How do you mean? Sorry,
So if you propose to enable multiple attachments to the same network through the hack of making multiple network attachment factory objects refer to the same network, that much you could do, but the spec says that when the CNI plugin is invoked, the network name that is given is the name of the network attachment factory object.
Yep.
So it will be given two different network names when it's invoked.
Correct.
But I thought our goal here was to enable multiple attachments of the same network.
Yeah, so what I'm thinking about it, or when I'm thinking about it, the underlying network is defined outside of Kubernetes and outside of the specification.
I'd say stay there. Yeah, it's outside of this specification.
Yes, it's outside of this specification. And so the description, the network description that we have in the object can be the same for multiple objects. You know, for example, you could include like a UID or something like that in the CNI configuration for this given network that would be the same for multiple objects, even though they have different names. That's one way to potentially get it. So then in your plugin, you would identify that network through the UID. If you have a long-running plugin or a thick type plugin. If you wanted multiple attachments to the same network using kind of the reference CNI plugins, then you would essentially just have the same CNI JSON and a different network name. Now, obviously, this wouldn't work for host local because host local actually uses the network name as part of its data store for figuring out what the IPAM should be.
So maybe I misunderstood something. There was some place in this document, I forget exactly where it is said that when the CNI plugin is invoked, the network name passed is the name of the Kubernetes object. No ifs, ands, or buts. And I think maybe you meant that the name is the name of the Kubernetes object if it's not otherwise specified, but it can be otherwise specified.
No, I had meant that the name of the Kubernetes object must match the name that is sent in the CNI config JSON when the meta plugin calls the configurations. So even if the name, so say you have a CNI config file on disk and this Kubernetes network object has a name, the meta plugin, at least in this spec, is required to replace the name of that CNI config on disk with the object, Kubernetes object name, to make sure that they are the same before it calls the actual plugins in that list. And the motivation there was to reduce confusion as to what exactly was associated with what. Because otherwise, yeah, you could have a Kubernetes network object that is named something completely different from the actual network name that is sent to the CNI plugin when the CNI plugin is invoked. And also due to this, you would not be able to use on-disk Kubernetes, on-disk CNI JSON with a different network name for multiple objects, if you get my point. Maybe not. That's probably not a very clear way.
Let's just try to walk through an example.
Sure. Okay.
So, right, we've got pod 1, and we want it to have 2 attachments to network 1.
Yep. And so let's say network 1 is defined externally to this specification somehow.
Right. So we need 2. You're proposing we're going to solve this with 2 network attachment factory objects.
Correct.
What are their names?
Network 1A and network 1B.
Fine. Okay. So when the metacode gets around to invoking the CNI plugin that makes attachments to network 1, for this pod, it's going to want to make 2 invocations. Let's talk about the first one. When it makes the first invocation, there is a std-in, right, is given some JSON, which includes a network name field. I forget whether it's called network or name.
It's just called name.
Okay. But it's intended to identify the network.
Correct.
So what value is in there?
That would also be network 1A or network 1B.
So how does the plugin then know that it's actually meant to attach to network 1?
Yeah, and obviously that's what you're getting at, and I understand that that is a little tricky. The problem that we have here is that CNI defines a unique invocation of a config or what have you as network name and container ID. So in this case, and this is through the arguments, the environment arguments, that's CNI network, I think is what it's called, and CNI container ID. So in this case, the container ID would be the same. For both.
There is also an interface name in the arguments.
Yeah, but that currently is not a unique key for any CNI plugins, or not defined as a unique key for CNI.
Well, we have a problem with CNI in general here. We're talking about an expansion of CNI semantics.
To some degree, yes. Yep.
This is part of it, right? The degree to which we're expanding the semantics is before now, CNI is only going to make a given plugin is going to make knows that it's going to make the one and only no to give that base, and we're changing it so it's going to be making several, one of several.
Yeah, I would say that's not entirely accurate. We are changing how, or we are discussing changing how CNI identifies uniqueness of invocations. Previously, CNI has always defined that to be the network name and the container ID. And so on disk, you technically could not have two files with the same name field in them and ever expect an invocation for the same container. I would point out that CNI was explicitly designed with multi-networkness in mind, and Rocket has always allowed that to happen. And that's why there's a directory for CNI config files at cninet.d. And the way that CNI originally worked before Cube came in and sort of restricted how it works was Rocket would actually execute every single CNI config file in etc cninet.d for a given container. So you were able to do that with Rocket, and since the beginning, that required individual network name for each of those configs. What we're discussing here is, and actually back up slightly and point out, I don't think that Rocket was really thinking about multiple attachments to the same network in the way that we are. So yeah, that is something that CNI is a little less flexible on.
Okay, so I stand corrected. We're restoring some of the generality that Rocket had and Kubernetes took away.
Correct.
That is the first and primary statement of this whole effort.
Yep.
And right now, with this multiple attachments to the same network, we're talking about an additional level of generality that was not even present in Rocket.
Yes. Yep. And originally CNI was, I believe it was the Rocket network code that then got split out into its own project and then evolved independently on its own for like the last 3 or so years. Okay. So yeah, that's why Rocket enters the discussion. So yeah, I mean, the two solutions to this currently are somehow explore changing the CNI spec to add multiple, or to add an additional point of uniqueness, whether that is the interface name or something else. Or the other option is to, if your plugin wants to support this, have some kind of additional identifier embedded in its configuration, like a UID or another network name that it uses to identify multiple invocations. And yeah, that's kind of ugly. It kind of breaks some of the nicety of having Kubernetes network names in the first place here.
Yeah, they both sound kind of ugly. I mean, changing something, that is agreed upon by a wide community is difficult.
Yeah,
it's the least technically ugly, but it's more practically difficult.
Yeah, and currently CNI defines a given. It does not allow multiple ads for the same network, and one of the reasons was that it would be hard to figure out. Well, that's not quite the right way to explain it, but CNI requires an add and delete pairing. So you can add a container once, and the next add is technically, there's supposed to be an error because CNI adds are not idempotent, because plugins are, it's harder to write that kind of plugin. And so to keep things simple, you can only do an add and a delete and an add and a delete. You can't do add, delete. We did redefine delete to be idempotent, so you should be able to do add, delete, 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 delete. And that was mainly because Kubelet was kind of brain dead and did that a lot.
Mm-hmm.
And so that's kind of where another reason the restriction comes in. But even if that restriction wasn't there, and currently you called add with the same network name and container ID, then most CNI plugins would assume that was for the exact same network and probably return you the same result, as opposed to doing an additional attachment. So yeah, so let's keep that as an open question. I mean, I can bring that question up in the CNI maintainers meetings. There should be one next week, so I can try to get some more information on that or see what other people think about this problem, and maybe they have some other ways to solve it.
Okay, please do.
Will do. Okay, so the last option there was resources instead, and that was brought up by Dan Henningsberg. I don't think he's on this call, but Jeremy is on this call, and he's worked a lot with resources. Maybe he has additional ideas there. I thought it looked like an interesting idea, but I feel like it would be something that would need more exploration and not something that we would be including in this particular spec for the moment, because it would require further changes to Kubernetes. And I think you had also brought up some of those changes, Mike.
Yeah, I actually think it's a bad idea because it's really semantic abuse. The resources field of a container is a different kind of resource than we're talking about here. As well as, to do this, we would indeed need to change the upstream code, which again is a ground rule that just puts it out of scope.
Which resources are you talking about?
So Dan had left a comment on the doc, and he said, how about specifying required networks as required resources within the container spec? This allows everything else that is defined in this doc, but also lets each node expose which CNI plugins are deployed onto it. He had also sent a mail to the SigNet list earlier, expanding on that a little bit.
Right, and so my semantic objection is that in Kubernetes today, the container resources are explicitly defined as compute resources and distinguished from API resources. And it says, noted, these compute resources are things that can be allocated and consumed. And there's things, right? The resources that the node has that could get used up by pods, and that's just not what we're talking about here. This is a different kind of resource.
Yeah, I think there are some issues, and I'm not sure if Dan understands entirely. Well, he says in the mail, if a pod needs access to a network, one of its containers should specify the vendor/name of the network as a required resource. On the other hand, nodes that have this network connected would have a vendor-specific device plugin advertising that they have access to the vendor/network name. When a pod is scheduled on a node, the device plugin is expected to allocate the requested device. For network vendors, this allocation would take place via an invocation of CNI. Does any of that make sense to you, Jeremy?
For our scheduling purposes, network was one of 4 or 5 different constraints that we're going to try and match against. This is verging on the resource class discussion that's going on. If you've seen that, we basically have, for any reasonable application, we're going to want, the network's one piece, and there's arbitrarily complex selectors that we need to be able to put in there. So that's resources. Resources normally we're talking about memory or CPU, but we're increasingly talking about any device plugin. And now we have the NUMA proposal, which you guys may have seen from Intel. So the way we are going to build these things is we're likely going to do admission controllers, which automatically taint certain pods, add tolerations to pods, and we will taint nodes probably with a daemon set that uses something like node feature discovery to see what's plugged in and what the node's capabilities are. That, I believe, is the way, at least in the resource management space, we're thinking of the full kind of user experience.
So Dan, to put this in perspective, right? I completely agree that network attachments may have implications in terms of consuming compute resources, but they are not prima facie compute resources, right? So you would use perhaps an admission controller to automatically add the scheduling constraints to deal with the compute resources that are involved in implementing network attachments. But a network attachment itself is a different kind of thing.
Yeah, I would agree with that. I can see cases where, if you need a connection to a particular network and the node does not actually have that, or if the node is not configured for a specific VLAN, or, the node doesn't have some kind of really fast 40 gig card or something like that you need. Those are constraints, and those are things that might map well to resources. But at the same time, if you're thinking about more of a software-defined network, that is kind of meaningless.
Well, those are more like the taints and tolerations. Yeah. For resources, you might think about something like virtual functions in a NIC, which only has 32 virtual functions, and they can get used up by network attachments.
Yep.
Right? Those are compute resources that the scheduler needs to count. But again, like the non-counted ones, these are consequences of the attachment. They're part of the implementation of the attachment. They're not the attachment.
Yeah. I would say for this, maybe we should continue thinking about it, ask Dan a little bit more what he means, and maybe keep watching it. Again, I don't think it's as relevant for this discussion at this point, or not discussion, but for this de facto standard at this point, given that it would probably take changes to Kubernetes itself. But possibly something to keep in mind. The only reason I thought it was interesting was that we could potentially piggyback on other infrastructure that seems fairly generic for some stuff, but then there's also the hardware resource stuff that scheduling already takes into account, and then the work with device plugins. But something to keep in mind, perhaps. Does that sound okay, Jeremy? If you want to kind of keep us updated on where things go with resources and if those continue to get a little bit more generalized, and maybe if you see further points for networking to use some of those things, feel free to jump in and speak up in the future.
Yeah, honestly, Dan, the more that we do on list and by recording these things, this time is not working for most of the people that I have allocated, unfortunately.
Okay.
But I did hear that that the resource class proposal has some legs inside Google, and we may move that up in the cycle. One of the key pieces that's missing from that solution is quota, and I think Derek's opinion was that we needed to quota these things before we can just turn people loose. And so we may have to do both of those before we sort of in parallel. I'll let you guys know, but I think one thing we need to do is sync with Doug. Is Doug on?
I saw him on earlier. Yeah, there he is. Hey, Doug.
Hey, guys. How's it going?
Hey, my question for you was, if you've had any issues standing up the CRDs and for your use cases, would you find the resource classes useful? Essentially, if anyone's not familiar, the resource classes allow us to select hardware based on metadata that something supplies, likely the device plugin supplies, such as the capabilities of the card, firmware levels, weird things like that.
I'm attracted to that. I did go through recently, maybe it was just before the last working group meeting, but I did do a stare and compare of the spec with the fork or branch that Corral had created of Multis CRD that matched the spec. And I was able to get that up and running with just a little bit of work that later went into that branch too. But it worked generally as a baseline. I need to circle back around to that and look at this new map structure that we've added there and put my hands on it and see.
All right. With that, we're almost out of time. Well, actually, we are out of time, but is there anything else that anybody wants to bring up really quick?
Nope.
All right. Okay, next meeting will be February 15th. And I know we've talked about, some people have brought up different times. I'm not really sure if there's a great time that works for everybody, but let's take that on list. I've sort of ignored those mails for the moment. But if anybody if we can arrive at a better time that works for more people, that would be awesome. I'm not hopeful, but we could try.
Maybe we can do a doodle poll to figure out if there's a better time.
That's true. It's a good idea. All right. See everybody in 2 weeks.
Bye. Thanks.
Take care.
Guys, yeah.
Bye, guys.